Okay, fine. Because I waited enough. That's fine. Now let's start. So we'll start with the architecture, which is the most important topic of all the things. That's the most important thing. Even you can attend interviews if you have knowledge on the architecture, so you can understand the importance. Okay, let me record it. Okay, it's getting recorded. Fine. All right. So yeah, so I have two types of things here. You have something called as a batch process flow, and you have something called as a real time. First, let's study the batch one because that's very simple to understand. Let me reduce this a bit. So this is the data flow diagram or the batch data process flow. Let's try to understand these points one by one. Plus, parallelly, what I'll do is this small demonstration that we have seen earlier, right, in the demonstration session. Now, I will also refer that so that you can correlate things, right? Okay, first to start with the architecture. So on a very high level thing, what is the definition of MDM? Because the architecture is goes with the definition, right? Definition of MDM, if I go technically, I mean functionally, you know the definition. Technically, if I go, then I will see that there is something called as, there are some systems which I'll call it as source systems, right? Then I will pull the data from the source systems into my MDM, something called as MDM, and then I will perform the match merge logic. So match and merge logic, and then I will the unique version of the truth, that's nothing but the master data, that will be stored here. And once you do that, you publish the data to target systems or downstream applications, subscribers, you can call them anything. So typically this is where MDM stands. You have source, MDM, target, right? So this picture also is pretty much the same thing, explains the same thing here. Now you see something like this like a box, something. Now that's the source. Then you see something like this, that's the target or consumer, downstream application, anything you can say. All right. And then you see something like a hexagon here, this hexagon. Now that's the MDM area. So whatever you see inside the hexagon, that's the MDM area, right? So now let's go a bit deeper here. So first thing, before we jump ahead into this thing, what is happening here, first let's try to understand the source system and then this arrow, right? So it means that I'm trying to understand this source system and then the arrow, right? So the source system, so what's so special about the source system? So the thing is, if in case of a data warehouse project or something else, you have restrictions, like you can only have an ODS stores or an OLTP system as a source to the data warehouse. Now that's called as a restriction. Why? Because that makes sense. Because why would I take data from a reporting application to data warehouse? Does not make any sense. But in case of MDM, there's no any hard rule that okay, this can be sourced, this can't be sourced, nothing, right? So what is what is the theory about the source system? The logic is simple, that if, let's say if I'm trying to create a customer MDM, mine is customer MDM, then any source system that contains customer information can be my source, right? Anything that contains customer information can be my source. So that's about the source system, right? Now talking about the arrow, arrow signifies how you are going to bring this source data into the MDM. Important? Of course, yes, it's important. So how do you bring it? Now that's typically done using an ETL. So you will see here that this arrow is nothing but that's the ETL area, or extract transform load, nothing like, I mean like power center, data stage, ab initio, ODI, something like that, right? Now, first thing is this mandatory that should I go with an ETL? Not exactly. It's not mandatory though. So if it's not mandatory, then why am I using that? See, it becomes mandatory when you have heterogeneous source systems. When you have homogeneous source systems, that is, this data type is same as this, you can go without an ETL. But when you have heterogeneous source systems, you must go for ETL. Why? Because try to understand this is MDM is MDM. MDM is master data management. It is not an ETL tool. It's not an ETL tool. It means that MDM does not have any data integration ability. MDM does not have any data integration ability. So to do data integration, I have to use a separate software. That's the ETL. So that's where ETL comes into picture, right? And using ETL like data stage or power center, data stage, power center are two most widely used for Informatica MDM also, not just in market. In market also they are the topmost, and in here also these two are used. Using that, you will pull the data into something called as the landing table, right? Now landing table is like the entry point. For example, let's say you go to a country, let's say you go to France, then the first place where you enter is that's the aerodrome or the airport, then the custom officials, then you enter the country, right? So that's the thing here. This is like your airport. This is the first place where data lands. Let's say you have gone for a business meeting, right? You will not do any business meeting in the airport, right? You will do it later. It means that this is just used to store the data. That's it, the landing area, nothing much useful. Whereas the real business meeting or the real stuff happens in this area, in this advanced stage, right? Landing, that's what landing means. Pull it, put it in a single table, right? Now how does it looks like? It's nothing but it's just a physical table. For example, if I go here and if I log in the database, then you will see that it's nothing but it's just a simple table. Like this is called as a landing table. 1 minute. So this is my landing table. You can see just like any normal table. And who is going to maintain data here? That's the question. Who is responsible for this landing table? The responsible guys are the ETL. The ETL guys will be responsible for loading, deleting, updating data in this landing table, right? First thing. Second thing, you can see here clearly that I have prepaid data, postpaid data, internet data. I have this three different types of data in a single landing table. It means that one thing is clear, that I might have 3 source systems or 4 or 10 or 15, doesn't matters, but I will use a single landing table for all the source systems. Clear? I might have 100 source systems also. I might have a source system called as prepaid, postpaid, credit, debit, anything, but I'll be using just a single landing table, not 100 landing tables, right? And how would I differentiate among the like how would I recognize that okay, this guy is prepaid, this is postpaid? Using a particular column called as SRC. So looking at this, I can easily I know this, that okay, now this guy is coming from internet source system, this guy is coming from postpaid, this one is from prepaid, and then I have different information. Then I might have, like, there can be a question like let's say my prepaid is using a dimension model and my postpaid is using something like an ER model, and my internet is using a denormalized data model, right? So how then it means that if it's using something like this, then there might be 10 tables here, and here there might be like 7 tables, and here that might be only one. It's just denormalized, right? And I have to pull the data from this source system into a common landing area. How would I do that? That's done using an ETL. Now that's what the ETL guys will do. They will do the joining and all the stuff. They will join this 10 tables or union it, whatever, right? And bring the data to a common platform, common stage. That's the concept. That's the landing table data, right? Now, so this is clear. 1, 2, 3, 4, 5, many source systems. I'll just load the data into one area. Now, first thing, so is it mandatory that you should have only one landing table? No. Technically, it's not mandatory. Technically, you might have thousands of landing tables. No problem. But normally, you will see that in 99.99% project, we follow this thing. Why? I'll come to that again. I'll explain this in some time. But anyway, once data is there in the landing table, then now try to understand that landing table is not a permanent table. It's just a processing table. It means you process the data, and once it's processed, you remove that, because that's what it does. It's just a processing table. All right. Now, when I have data in my landing table, let's talk about this this example. So I have the customer coming from 3 different source systems. So in my landing table, I have 3 records. Now the logic architecture is like this, that I will use, see here, try to understand this. First of all, before going that deeper, there are 3 types of tables in MDM. One is something that you know already now, that's called as the landing table. Second one is the staging table. The third one is the base object, or you can say the master table or the base table. We call that as object, base object. You will see 3 different types of table, right? And this is what it is showing, the landing table. Then you have the landing to staging, then staging to the base object, staging to the base object. All right. Now, so why this? I mean, why do I need this? Why can't I just, dump data in here? What's the point of using middle stage? The significance of this middle thing, okay, the significance of this middle thing is it signifies cleansing, data quality. If we are talking about any data quality things, anything regarding data quality, then that's handled here between landing to the staging area. You see something called as mappings. That's the data quality mappings. What does it do? Identifies DQ issues and corrects that. Right? Now when we talk about DQ, and first of all, how would a mapping look like? A mapping is something that looks like this. So a simple mapping, this is a simple mapping, and if you talk about complex mappings, which we will do it, so it's something like this. So it looks like a spider web here. You can see here there are a lot of things that you can do, okay, many things in addresses and all that, right? So this is something that we'll do in the labs. Now anyway, let me go back to this. But anyway, this is like a simple mapping. So mapping is something that loads data from the landing table to the staging table. This is the landing table, this is the staging table. So remember this, that you will hear only this term once, mapping. You will not see concepts of mapping anywhere after that. Just here you will see the concepts of mapping. You will not see anything here, anything here, anything here, nowhere, right? That should be clear. Now, for example, what I have shown you here, right? What exactly is this? What am I doing here? What I'm doing here is I am trying to transform the data, or I am trying to identify data quality issues and correct that. What kind of issues? So something like this. Let's say if I go to this mapping sheet, then for example, see here, remove noise and digits, trim it, title case that, and then the reject if it is null, then do a blacklist check, right? So I want to make sure that the data that I'm going to store is perfect. Why? Because if I store junk data, what's the point of creating a master data, right? And that thing is done typically here. And when I talk about cleansing, or you can say cleansing or mappings, both are the same thing. Cleansing is done inside a mapping. Okay, that's what is the English definition. Now when I say cleansing, I think it's already there. Yeah. So when I talk about cleansing, then cleansing, it's a broader term which could mean many things. Like it could be validation, then your standardization, your third one is enrichment, then the fourth one is your cleansing. Now when I say mapping or cleansing, pretty much these four things happen inside a mapping. And moreover, these are theoretical concept, but it's important for you, right? Let me try to correlate this with practical reason. You will see these terms very often. I mean, you will hear these terms very often in an MDM or a DQ project. Validation is very simple. Validation means you validate the data to make sure that it's valid. Valid means it meets a certain standard. That's what is the meaning of validation. All right. Now, when I say that, let's say that your house number, sorry, your postal code is AUTZ 78, something like that, your postal code, and that's California. Let's say Los Angeles, in some particular area, that's the postal code. So let's say the customer is giving this information. How will I validate and make sure that it's valid or not? Very simple. I will have a database, and that database contains correct information. So I'll just check this data against that database, and if the entry is there, it's valid, otherwise invalid. That's what is the meaning of validation. Okay, validation is very simple, you already know this. Then standardization, which is also a common thing. Standardization, now it's difficult to define standardization in technical terms, but functional terms it's very easy. Standardization means standardizing the data. It means like you have something like source standard, then you have MDM standards. For example, let's take an example. Let's say that I am currently here. Let's say that I'm wearing shorts or jeans or something, right? And some different uniform. Let's say that's my standard, just casuals, right? And let's say that in a school, high school or a school, you have a different standard, you have a uniform. All right, now let's say that if I have to go to the school, then what I need to do, I need to don certain clothes like particular uniform, tie and all those stuff, then only I'll be allowed, otherwise not. So it means what I am doing, I have a standard, the school has a standard, I want to go to the school, so I'm converting my standard to the standard of the school. That's standardization. So it means you have source systems, you have MDM. The source system data might be in a different standard. To convert that to MDM standard, that's standardization. So for example, let's say that I have the country name as IND. In one of my source system, let's say CKR, in this source system, the country is IND. In, let's say, in CKR, it's IND, means short names, not full name. In MLO, this is in codes like 09101, something like that, right? And many different source systems have their own standard. But in MDM, as an MDM architect, I have defined the standard. I've defined that, okay, the standard is that I'm going to go with full names, that is INDIA, India, always. I don't care what's coming from the source, but I'm not going to allow anything apart from India. It means, what is standardization here? Standardization is a process of converting IND to India, 091 to India, or Republic of India, or Hindustan Bharat to India. That's what is standardization here. Alright, now another example of standardization would be, let's say that my source contains lowercase and mixed case and sometimes uppercase, like that. But in MDM, let's say that I will store only uppercase, then what is standardization? It's a process of converting, is a process of where you convert this to uppercase, right? That's what is standardization. Now enrichment is also very similar to standardization, but they are not same exactly, they're slightly different. Enrichment means you enrich the data to make it more useful. That's the English definition. Now if I go a bit deeper, let's say that I have a big stone. Now that stone contains some gold, so I know that has somewhere around, let's say, some pounds of gold, right? Now if let's say my friend is dropping by, I'll just tell him that, you see this stone, I want to sell it. He'll say that you're really stupid, because he'll not understand the uh, precious, or whatever you say, the value of the stone, because he can't see that. You know this, but he can't. So it means that data is there, it's useful data, but the currently you can't use it because it's in a non-usable format, right? So identify that there is gold. It means identify that, okay, there is something useful in that, and correct it. And once you, let's say, take the gold out of the stone using some metallurgical methods, then if you say that I would like to sell it, you'll see 100 guys appearing at your doorstep, right? So let's say that AUHG, or let's say that um, let's say this is the pin code, okay, for LA. Let's assume this is a correct pin code for let's say Vegas. All right, now what the customer has done is he has given this information. So the pin code is correct, but this city is incorrect, or the street name is incorrect, right? Now what is enrichment here? Enrichment is a process of identifying that, okay, the customer's intention was not uh, to commit a mistake, but that happened accidentally, and to identify that, okay, this is something that's not wrong, but it's a mistake, and then correct it to Vegas and use it, because there is nothing in the world called as VEG. So you keep on searching for a city called as VG, you will not find it. So this is useless data, but I'm making it useful by converting it to Vegas. That's enrichment. And cleansing means you clean the data. I mean, you see a lot of unintentional stuff, like let's say, call me, something like this, right? Now that's what is there in the phone number field. Now in the phone number field you see something like this. Now that's what is wrong with that. I don't expect this one. This is something that's a noise. So you remove that. That's called as cleansing. You clean just the way you clean your home, remove unintentional stuff. Same thing here, right? And with that, that's what is the cleansing. So the four things that we have discussed here, all these four things we'll see when we start with the lamps. Then we'll see the mapping sheet, how to implement the standardization, validation, all those things. We'll see that. No need to worry. Now talking about the second option, delta detection. Delta detection means, we'll see delta detection in details later, how the logic works, but here I'll just give a high level thing. Delta detection is a feature where you identify the changed data. Okay, so if nothing has changed, then we don't process that. Alright, now let's say that you have processed 10 million records today. Let's say today you process 10 million records. Now after 10 days, again if you process the 10 million records, what is the problem? The problem is you're wasting your time, my time, computer's time. Because see, already the record is in there. I mean, it's there in the database. Why you again try to process it? What could you possibly gain? Nothing. But if the address of some guys have changed, then you might want to process it. So you process only that data that have changed or new or deleted. You process only these things. How do I do that? Now that's the process of delta detection. How it's done? It's typically done, we have something called as a PRL table that's compared with the landing table, right? And then the delta is calculated, which we'll see later. Let's not jump into that, but just understand that delta detection is, that's what it does, identifies the change data. Now what's so special about this? It's not special, but yes, slightly, of course. The reason is delta detection is in here. It's very simple to configure. It means it's a feature. All right. Now you will see that if I compare this with ETL tools, now in ETL tools, you will not see any feature called as delta detection. Either it can be like any of the ETL tool. You need to create the logic stating that, okay, where last update date is greater than $$ last update date, okay, or you create a control table and then do that, or you use something like Power Exchange or something like a Golden Gate, different software to do that. But in MDM, that's very simple. It's something that you don't need to really try, like, see here, go here, click this, done. That's it. Delta is configured now. It's very simple to configure delta in Informatica MDM. Why? Because it's just click of the mouse. What these three buttons are, which that will see data. All right. Now, so that's a good feature. And then I have something called as the raw. Now raw means raw. So just like raw foods, raw vegetables, something like that. So here also we have seen something called as raw. Here also we are seeing something called as raw. Raw means it's just landing data. Landing means raw data. Okay. Raw means we are not doing any data. We have not done any data quality or anything yet. That's called as the raw data, as it is from the source. And here also it's raw. It means that this raw is nothing but it's a copy paste of the landing table data. Copy paste of the landing table data. You might have a question that, right, like why would I do something like that, copying and pasting the data? What's the point? All right, the point is it's about backtracking. So for example, see this, if I go here in the tool and select that and 1 minute, select this and say that 5 loads. It means that either I can do it in 5 loads or I can say like a month, 1 month. So for either for 1 month or for 5 consecutive loads, you will see that the source data, that is the landing table data, will be archived in my raw table. So in this case, let's say how much data will I have in my raw table? I will have data of 5 loads. What about the 6th load? When I run the 6th load, what happens? The first load is erased, right? Now, but why would I do something like that? That's the reason is backtracking. For example, let's say that I have, this is the data flow, starts with the source, goes like this, then here, then something like this, then it's done. That's the flow of data. Now let's say you face any issue here in this area, you face an issue. What you can do, what you will do, you will, if you're intelligent, I mean that's the normal thing you are. Now if that's the thing, then what you will do is you will backtrack it. Now backtracking is a process where you go back the way you started, just follow the same path. So you go back like this, here, and this, and then finally to the source. Why? Because now that's where the data started, from the source, isn't it? So, but I have a problem. The problem is my source system can be an OLTP system or an ODS stores, or it can be a very critical system or something very important. When I say important, it means that I can't access their database 24/7. I can't do it. Alright, now let's say that, so in these cases what will happen is they will give you a time window that you need to access our database in this time zone. Let's say from 9 p.m. to 11 p.m. Let's say you get some issues here. Let's say you are facing an issue at 1 a.m. in the morning or midnight. Then what to do? Can you check this? You can't, because you don't have access anymore. So that's where we use this concept of raw, basically used for backtracking, right? That's one reason. Second reason is you might have this one in for example, like XML files, what someone was explaining, XML files. Now I don't want the headache of checking data in the, at least I don't like it. So going there and checking in the XML files, that's headache. So to prevent that, or it can be in your mainframe machines. Now I don't want this headache also, checking data in the mainframes, doing that matrix type of movie. So that's something that I don't want. To prevent that, I have something like this table that comes into play. That's all what it does. And how it looks like, this is nothing but it's just a physical table. So this is how it looks like. For example, you have seen the landing table. Now let's see the staging table, how it looks like. One minute, let me, okay, this is prepaid, not secure. Actually, we'll not be following this data model anymore. This is just for demonstration, prepaid, postpaid internet. We'll be following a different thing, that is this one. Okay, that is just for 2 days I'll use it. After that I won't use this prepaid postpaid. Anyway, this is my staging table data. And what about the raw table? This is underscore raw. Okay, so that's called as, that's my raw table. If you enable that, you would have seen data here. All right, and then the final step of the process is the reject. Now reject means, it's very simple logic, that if your data does not meet a certain standard, it will be rejected. So what's that standard? It means if you're trying to insert duplicates, exact duplicates, or if you're trying to insert null values into a not nullable column, or if you're trying to insert data type kind of issues, or uh, invalid values in restricted fields, something like that, then you have issues. And that I have already documented here. So if you go through this, then you'll understand that this one, rejected. So these are all the reason for rejection: null primary key, all those stuff, hub state indicator and all that, right? And that's one way. That's the automatic reject. So that's called as the, 1 minute, auto reject. Auto reject in the sense you don't have much control over that. So you don't control it. Informatica will control it. Alright. Now then you also have something called as manual reject. Manual reject in the sense you have complete control on the rejects. So you are going to decide on what condition data will be rejected. So let's say that if name is null, reject the record. Can I do this? Yes, I can. That will be called as manual reject, which we will see, right? And manual automatic reject, you don't have to do anything, so that's automatic. Manual reject, for manual reject there is something called as a reject function. We have to use this feature to reject the data. Okay. And right. And how a reject table looks like? This is something like REJ, right? You don't see anything, any rejects here now, right? Now if I go here and let's say that I'll show you how data is rejected. Let's say that I use a how to do that, we'll see that later, but I'm just quickly demonstrating it. So let's say that I will just connect this and add a constant and say this thing. Okay, so alright, now save it. Now if I run the mapping, then you will see that data will be rejected. So if I go and 1 minute, I did the change in prepaid. So if I go and run this, you will see that data will be rejected. The more of it which we'll see later, not now. So you can see data is rejected, and as a result you will see that this table is filled. Okay, that's the simple demonstration of reject. And you can give a reason also, just testing. That's what I gave, right? And then just remove that. It's not necessary. Alright, save that. Okay, that's what is the meaning of this thing. Now talking about the staging table, so you can see the convention here. Can you see this, that I have this C staging party, then I have something called as a source system name. It means that I have 3 staging tables. I have this, I have this is something called as postpaid, and that's internet. Alright, now I have 3 staging tables. I have 1 landing table, I have 3 staging table. That sounds strange, right? Now that's how it is. So it means that if I go to this picture, then see here, I have this source system, this source system, this source system, 3 source systems. I will pull all this data into a common landing table. Now that's my landing table, and then again from this landing table I will pull it into different staging tables, and then from the staging table I'll load the data into a table that's called as the base object. Now you might be thinking, why this something like a circus? Like, is it necessary? Yes, that's necessary. It's necessary. Why would I need multiple staging tables? Try to understand. Multiple staging tables means privacy, in the sense that for every source system you're going to have a different mapping. So Let's say for prepaid, this is a different mapping. Like here, for prepaid I have a different mapping, postpaid different mapping, internet different mapping. Is it necessary? Yes, it is necessary. Why? Because you have 5 fingers in your hand. You think, I mean, you know that they are not same. You don't have to think, you know that they are not same. They are different. Similarly, when you have 5 source systems in your company, they will never be same. There will be DQ issues specific to certain systems that might not be there in other systems, right? Now, so it means that you will apply different data quality rules to different source systems. Now that's why it's important that I have 3 different mappings and I have 3 different staging tables. So that's why this diagram, like multiple staging tables, is important. And then from this staging table you just pull the data and load it into the base object. So here I have 1, 2, 3. Then all these 3 I will load it into a single base object. Now you might be thinking that I spoke of mapping here, but why is that I don't need any mapping here? I don't need any mapping because it's auto mapping. I mean, it's internally done. Then you might be thinking like, how would Informatica possibly know that, I mean, how to map what data to what? How, I mean, how does it happen? It happens because if you see the process of staging table, you will see that this is called as a base object. Alright, now you see 3 staging tables. Now these 3 staging tables are created inside the base object. So inside of it, you will see this is how it's created. If you want to create one more, then you just need to create it here. Alright, just create, say, add staging table. That's how it's done. Right? So it means that, and see this, when I'm trying to create it, you can see that automatically these names are coming. From where? It's coming from the base object. So you are not independent here. You are dependent. It means that the staging table is like a subtable of the base object. So since it's a subtable, Informatica knows what to map. So you don't have to specifically tell Informatica that do this, do that. Right? And so this is clear, right? I have, again, I'll try to sum it up, then we'll proceed. Common landing area, then staging, 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 then this. Now let's talk a bit more on this area, right? Now pretty much it's like one-to-one. You just run a job. If you run a job, then it loads the data from the staging table to the base object. So what's the specialty here? The specialty is, it's nothing, just 3 things are there. I mean, just 3 things are there. 1 minute. That is, yeah, see here, I have something called as trust, validation rules. So 2 things comes into play. Now something called as trust means the survivorship. So what we have seen in the last demo session, I've shown you that we have something called as scores. So you have different scores, 90, 80, 70. So whichever has the highest score will be the winner or the survivor, right? Now that mainly happens in the merge, but let's say that when you're loading a record and it's coming from internet, the score is 90. Then in the base object, the record will be loaded with the trust as 90. Okay, so trust comes into play, but not a major role, simple role here. Okay, just simply used. And talking about validation is an enhancement to trust. It means that, see, there are 2 types of validation. One is something that you have seen here in this area. That's true validation. Now this is fake validation. In the sense, this is not actually validation, slightly misleading. So what this means, this validation area means is, see, this is a supportive to the trust. What it means is that, let's say that if the trust is 90, so you got a record called as John from prepaid. So what will be the trust of this guy, John? For name it is 90. I got Amit, is 90. Definitely all will be 90 if they are from same source system, right? Now what I want is, I want if the characters or if the length is less than 3, then I feel like if the length is less than 3, it can't be valid. So what I'll do is, I'll try to then reduce the trust by 50 percentage. So let's say that you have a guy called as Aeon. So for Aeon, you will see that the trust will be 45. That's what is the meaning of validation rules here, right? So don't get confused with this validation and this validation. They're different. And finally, one more thing that's not demonstrated in this picture is the referential integrity check or the lookup translation. Now that's typically done from staging to the base object. It means that, see, there are two types of table in the world, like parent, child. Alright, now when you load the parent, no problem, you can load it. But when you load the child, you must make sure that the parent is loaded already. If not what? If not means you will see that you will see issues, you will see rejection. So that's what is this referential integrity or lookup translation. We'll see more of that later, but just understand that the referential integrity check happens in this area. And then I have data in my base object. So if I try to just demonstrate that, then see, I have something called as the stage jobs. Stage job is something that will move data from my landing to the staging table. Then I have something called as my load jobs that will move the data from my staging table to the base object, right? So let's try to run this and I'll just show you the data movement of data. So I can run them one by like individually, or I can create a group and do that. So what this group will do is, it will move the data from here to here and here to here in a single job, single step, right? So if I go and run it, okay, now you can see that my landing table had 3 records. Now my staging table, 1 record, 1 record, 1 record, and the third type of table now. That's the third type of table is nothing but my base object table. So that is this one. Now 1 minute, the match and merge is also done. Okay, 1 second, I'll just show you the load. 1 minute, I'll just remove the data and show you once again. Okay, data is removed now. Now let me rerun the job. So match and merge I'm not running. I mean, I'm just running the data till this, from here to here, here to here. So what's my expectation? What can I expect? I can expect that, just see here. So here I will see 3 records, which I'm seeing 3 records, right? So 3 records here, then 1, 2, 3, then 3. So it means that if I try to summarize it, what I've done, then what I've done here is, this is what I've done. So different source systems, pull that into a common landing area, then from there to again different staging tables, right? And from that to a common base object area. So that's all what I've done. It means that If I remove this headache, then all what I've done is I just pull the data from the source systems and dumped it into my base object. What about the match and merge? Because you can see that party table is my main table. Party table is the main table, and you can see that this is a master table, and you can see duplicates here. Can you see that? John Smith, John K. Smith. You can still see duplicates here. So is that a problem? Absolutely not. I mean, it's a problem, but that's part of the architecture. So the logic is like this, that initially duplicates will be loaded into this in this table, then you will run the match and merge process, which will identify and eliminate the duplicates. Simple logic. Identify and eliminates the duplicates, right? And that's what is done in this area, and that's what we'll learn in this area. But one thing is clear, that this logic is clear. So here to here, here to here, and to here. So this is one phase of the architecture. Now what I'm going to do is start the second phase, but before that I would like to understand if you have any doubts or anything, then I'd like to clarify that, then I'd like to proceed further. So if you have any doubts on this area, anything, you can ask.
I'm just a bit confused about why we should have only a landing table, be one landing table. Since we have a staging, we have three different tables, and even the base objects as well as source
Yeah,
system.
it's
So what is the harm? What is the harm? We're having a three different landing tables actually
yeah, the
instead of having
harm.
one.
Yeah, let's see what is the harm. The harm is, let's say, landing table stable base object. Okay, so in my case 1 3 1, right? Now let's take another example where I have this as 3. What's the problem? See, here how many source systems? 3 source systems. Here how many source systems? 3 source systems. Okay, now see here, if I add 5 more source systems, then what I need to do here, no action. I don't need to do any change here. Here I need to add 5, here I need to add 5, here also 5. So you see this additional effort of maintaining additional tables, which is not necessary. So you're doing something that's not needed. So that's the problem. This will run into performance issues later, plus maintenance issues. Let's say if I have 100 source systems, then 100. So then I have 100 here, but I have just 1 here. So this is quite easy to maintain, whereas this is a headache. So that's why it's always better that you use a common table, a single table. So that's the reason why you'll see in many implementations it will be this, not this. But technically both are possible. Okay. Right. Any more questions? Anything else?
Sunil, will there be any such situation where you'll have to maintain different landing tables?
You might have to when you have combination of delta and full loads. So for that, for delta you might have to go with separate landing, and for full you might have to go with separate landing. But otherwise not. Yeah, otherwise not. That's the only exception. Okay. All right. So there are no doubts.
Sunil.
Yeah.
Yeah, Sunil. Landing table is nothing but the ETL point of view, it is a target table, yes?
Yeah, exactly. For ETL guys, that's like a blind target. So that's where you dump the data for ETL guys. They will.
All the transactions.
Yeah.
All the transactions performed in the table itself, yes?
All the transaction.
Yeah, ETL transactions. like it has
Yeah,
separate
that's
scenes and
correct. So ETL will have, like ETL guys will have only that much visibility. They will only view something called as a landing table. So after that, no, not after that. So just they are responsible for interacting with the landing table, loading data, updating data, deleting data, all that stuff. And this about one more thing about landing table. Now, if I go back here, now this is my landing table. So let's say that today I ran this job. I processed these 3 records. Now tomorrow, let's say in prepaid, I have 5 new customers. So what I'll do now? What I will do is I will remove this data, just this one. This is called a slice. One slice, I'll remove this one and then load the 5 records and process it. I don't need to do any change to this. Why? Because let's say that you run the prepaid job at morning and you run the postpaid in afternoon, something like that, different schedules. So you should not touch the other slice. Okay, that's how you control the data slice wise. And that's a very easy thing that can be done in the ETL. You create views on the top of these things and you insert data into the views, which will do it in the table. Okay.
okay. How to maintain the historical data in the MDM?
Historical data, you're saying SCD type 2, something like that.
Yeah, yeah.
Yeah, so for something like that, you have something called as dynamic timeline. So there is a feature called as dynamic timeline, that is this one. So if you choose this, then this table will be used as SCD type 2, that is start date and date will be used to maintain different versions. Okay.
Thanks a lot.
Yeah. Right. And for example, I think this ORS sample will have multiple versions. I'll just quickly show you that. I'm not sure if it's there or not, but it should be there, I think. The okay, I think it's not enabled, but if it's enabled, you can see the started ended and multiple versions. Oh, okay. Now,
Hi, Sunil.
yeah,
And for every job, I think first we will do full load. After that, we will do delta load.
correct. That's the same process here as well.
Then you said that for delta loads, so if you have full load and if you have delta load, then we need to maintain different landing tables.
No, no, not in that sense. What I said is see, I'm talking about delta detection. Okay, see, some source systems will give only full files. They will not agree to give delta files. Okay, they will just say that you take the full file, you do whatever you want. We don't want the headache. Now there will be a lot of teams like that, and there will be a lot of teams, source systems, that will say that we'll only give you delta files. We can't give you full files. We'll just give you once, and after that only delta files. And if you want a full file, we'll charge you heavily. So you have many source systems that will give only full file. You have many source systems that will give delta file. Now, if in this case you don't use delta logic in MDM. Why? Because that's not necessary. That's not needed. But here, use the delta detection technique. Use the delta detection technique. Now in this case, if you go with the landing table, you will see something called as contains full data set. It means that delta is enabled for this landing table. Alright, now if I remove that, delta is disabled now. So for these source systems, you enable this, and for systems like this, you use a separate landing table where you don't select this option. That is the meaning of that. Okay.
Okay.
So now data is in my base object, and if I go and check it, then I can see that I can see here that I have 3 duplicate data. But now we are talking about something called as consolidation indicator. Consolidation indicator is a flag, or you can say it's a column in the base object. Now this will have values like this. This will have 1, 9. It can have 5 different values. 4 means you can see that it is 4 now. So 4 means new guy. So new record. It means when you just load the data, it will be 4. So when will this change to 3? Sorry, this is 2. So when will this change to 3? This will happen when you start the match job. When you start the match job, this will become 3. Okay, 3 means queued for match. Queued for match. So what is the difference between 4 and 3? They are pretty much same. Just the only thing is that the match process has been kicked off here, but here not yet. Alright, so here will I have duplicates? How many records will I have? 3. In our example, here also it will be 3. So they are pretty much same. Only thing is match is kicked off here. Now once that is done, then the matching will happen. Once the matching happens, then you will see that once the matching happen and it's done. Once it is done, then it becomes 2. 2 means matching is done, but it's pending for merge. Queued for merge. It means you understand, right? Matching is done, but it's just waiting for the merge, right? And then you run the merge job. When you run the merge job, what happens? The duplicates are gone. So you have the master data here. And 9 means on hold. I'll explain it again. See, initially it is new record, and when you start the match job means something like this. That is this job. You just go here, right click and execute. If you do that, then it will become 3, and then finally it will become 2. So internally it will become 3 and then 2. For example, see here, currently this is 4, right? I'll just go and start the match job, let's say. So if I do that, matching will happen, and you will see the status as 2 now. So 4 to 3, 3 to 2. 4 to 3 happens very quickly internally, it will happen. You can't see that. 4 to 3, 3 to 2. So this is 2 now. 2 means what? So do I have duplicates still? Can you see duplicates? I can see that. I can see that still there are duplicates, right? So here it means queued for merge. It means how many records will be there? 3. It means that dupes still there. Here also duplicates are still there. Here also still there. Then I run something called as the merge job. So that is nothing but this. If I do that, then the duplicates are gone. So the duplicates will be gone, and you will see this will change from 2 to 1. That is, this is 2, and now if I execute it, this is 1. And you can see that the duplicates are gone. No more duplicates, right? So here, no dupes. So except this phase, this stage, you will see that duplicates will be there in every step. Right? Now 1 means that's the final step. We are done with the final step. That means master data has been created, or you can say it's ready for consumption. 9 means on hold. On hold means what? This is the life cycle of a record in MDM. 4, 3, 2, 1. Life cycle of an record in MDM. Now if you don't want a record to go through this cycle, then you change it to 9. 9 means you put it on hold. So you don't want the records to participate in any of this process, right? Then that's called as on hold. Okay, I think it's time, so we'll finish the session also. Yeah, so we'll finish the session. Now tomorrow I will show you this one. This is almost like the same thing. The match, auto merge, manual merge, we'll talk a bit more. Then we'll see the real-time architecture plus this software tier architecture, how the three different tiers are there and all that. Okay. All right. Now, if you have any questions or anything, you can ask. And yeah, tomorrow the class timing will be 7:45 a.m. IST, not 8. Okay, 7:45 a.m. IST. Yeah. Okay. You have any questions or anything? Any concerns? You can ask.
Actually,
I
the one last you told, the one you last told you new record queue per match, queue per match. Once, can you please tell? Can you please repeat once again?
Q. Yeah. 1 minute. I'm getting a lot of disturbance. I'm muting everyone. Okay. So see here. 4 initially. Then when you start the match job, it becomes 3. 3 means, for example, 4 means it's still in, I mean, he's in vacation. So this guy is in vacation. 3 means he's still in vacation, enjoying, but he got a call from the office that, okay, you need to work from home. So it means the match has been initiated, but nothing has been done yet. It's all the same, right? Then the real thing happens here. When you run the match job, then the matching will happen. So here the duplicate identification will be done. So Informatica will identify that, okay, John Smith, John K. Smith are all the same. And once the identification is done, then immediately the status will change to 2. 2 means Informatica has full knowledge that, okay, these are duplicates. You understand? 2 means Informatica knows the duplicates, but it can't do anything. You understand? It knows that, okay, these 3 are duplicates, but it will not eliminate that. Why? Because that elimination happens when you run the merge job. When you run the merge job, then duplicates will be eliminated and you have the one master version, master data, right? 9 means putting records on hold. If you don't want anything to the records to participate in this process, you make it 9. So if a record status is 9 and if you run the match merge job, it will not participate. That's the meaning. Okay.
Sunil Sivai,
Yes, you are.
can you go for architecture slide?
Yeah.
Not this one actually, that staging you have explained. Yeah,
Yeah.
this one. Actually here raw data you explained, right? Raw data in the sense is it same as whatever data in source without cleansing or after cleansing?
Wow, that's a very good question. Yeah, now the question is, I'm getting some disturbance, so I'll mute you. Right. So yeah, so the question is, so when I say raw, right, is it the, first of all, raw table is like staging underscore raw. So there can be a confusion that is it cleansed data or is it raw data? So this is not cleansed data. This is raw data. Raw data means it's picked from here, not here. Okay, it's picked from here. This is the correct procedure. And there can be another question that when I have multiple staging tables, I have multiple raw tables, because raw is nothing but staging underscore raw. So underscore raw, that's the raw table, right? Now, so I have different, so one thing is clear, I have 3 staging tables, I have 3 raw tables. Yeah.
Okay. And then one more question, Sunil. Actually, suppose we have 2 or 3 source systems, and in that case we have only one landing table, or as
One,
which number
one,
is suppose
one,
one.
one. Yeah.
How we can relate the structure? Suppose source structure is different. Suppose in
Yeah,
one
that
source
will,
system has
yeah, that will be done in the ETL. The ETL guys will perform the mapping using the joiner transformation and all those things to load the data to a generic format.
okay. Before landing, we are generating a unique format for landing, right? You are
Exactly.
saying.
Right.
Yeah. Thank you, Sunil.
Okay guys, you have any questions you can ask, otherwise I think we'll finish the session. Okay, right, I think so. If there are no more questions, then I'll finish the session. Thanks.
Sorry, Sunil, one more question.
Yeah.
Sorry for that. Yeah, actually, as a Informatica MDM developer, our scope will start from is in this
From the
right?
landing table. From
From
the
the
landing
landing
table.
table.
Yeah. So whatever you see in
Okay.
the hexagon, that's your responsibility.
Okay. Thank you. Thank you, sir.
Okay. Thanks, guys. Then we'll meet tomorrow. And timing again, I'm telling you, 7:45 a.m. IST. Thanks, guys.
Thanks, sir.
Yeah, thanks. Bye.